Well, hello there. So let's talk about H bridges and how you can use them to control motors. So here's the general layout of an H bridge circuit. So an H bridge consists basically of four switches, or it might be transistors acting as switches, but you have to be able to break the circuit in four different places. There's a voltage source. Sometimes it's top and bottom. Here we have the voltage source on the left with the plus terminal on the top and the minus terminal on the bottom. And then the motor goes in the middle of all of the switches, and that gives us our H shape. So there, there, and there, we get an H in the red. So to make the motor go forward and reverse, we close switches in different patterns in order to connect the motor wires to the power wires. So with a DC motor, if you flip the polarity from plus to minus and minus to plus, the motor goes in reverse. So that's why we need the four switches here. So to go in forward, we would close, forward is relative, could be reverse, but forward we're calling closing switch 1 and switch 4, like that. And now the plus current comes out through the closed switch into the motor, runs the motor, and then back to the battery through S4. And S2 and S3 are open, and that's our forward direction. Reverse is the other pair, so we open S1 and S4, and now we've closed S2 and S3, so the power comes this way, the current flows plus, so the plus is coming in the right side of the motor, which makes it turn the other way, and then back to the battery. There are a couple of other configurations. This one is called the break. That's when we basically short the motor wires together. So here, both motor wires are connected to ground by having S2 and S4 closed, S1 and S3 are open. This gives a braking effect because when the motor is spun by an external force, it acts like a generator, and if there's no load on the generator, if the motor's not connected to anything, if the wires aren't connected to anything, then it's easy to spin. But if you short the wires together, then it pulls a lot of current from our generator, and that slows the motor, makes it harder to turn. So it's important to realize that this brake mode only slows it down if it's trying to spin. So if the motor's spinning, it will be harder to spin. It doesn't really give you a holding force of any kind, though. You can also short the wires together on the plus side by closing S1 and S3 and opening S2 and S4, and you get the same effect. Here is a bad combination of switches. If you close S1 and S2 at the same time, then your power avoids the motor and just has a short circuit. So this is either going to blow a circuit breaker or a fuse or start a fire, something. This is a bad combination. You can get the same combination if you close S3 and S4 at the same time. Most people know enough to not do the short circuit, but it happens sometimes when you're transitioning from forward to reverse or reverse to forward if you're not careful. And it's because the microcontroller that you're running your H-bridge with, probably you have to change each pin one at a time. So if one pin changes at a time, you're going to be in a transition state. And so you want to carefully consider the order that you change. So I'll show you a bad order of going from forward to reverse. So here we're in forward with S1 and S4 closed, S2 and S3 open. We want to switch to the reverse configuration. So if we close S2, now we're in a short circuit. And so we just blew the fuse. Even if this happened for a millisecond or a microsecond or something, probably still going to blow that circuit breaker. And we're not fully reversed. So then the next maneuver would be to close S3. And now we've got double shorts. So if it didn't blow the circuit breaker yet, it's going to do it now. Now we're opening S1, so we've cleared that short, but we still have a short over here. And then finally we open S4, so we're back in the reverse mode and safe again. So when you're going from forward to reverse, if you're changing one pin at a time or activating one switch at a time, make sure you turn it off by opening all the switches, then close in the new direction. So the chip that we're going to use in our Mechatronics class is the L298 chip. It has 2 H bridges implemented on the single chip. It's a very old design. It's not very efficient compared to the low resistance that some more modern motor driver chips can achieve, but it's cheap and it's reliable, so we've chosen it for this class. And it has a limit of about 2 amps per bridge, so that's pretty small motors. So the motors on our robots are an amp or 2 when they're stalled, so that's appropriate, but you can't use this on an electric bicycle or lots of other senior project kinds of things. I see students overload these sometimes, so be aware of the maximum current here. There's a 46 volt maximum rating on this chip. I think if you're anywhere near, particularly the voltage max, and probably if you're running consistently at the current max, you need to be careful and read the datasheet, because sometimes these have footnotes, only if properly heat sinked, only if you do certain things. So be aware if you're close to the maximums, you'll want to read the datasheet. And the datasheet's on our Brightspace page. The chip comes in this kind of strange format. This is the one that you'll see very often with the through-hole pins. They're arranged so you can't plug it into a breadboard. They're staggered, offset a little bit. So this isn't breadboard friendly. There's a surface mount chip that's the same implementation, but it solders on top instead of through holes. And you'll see both of those on the modules that we buy. So here is a schematic of the L298 dual H bridge. So we've got 2 H bridges here. So there's one on the left, this is an H bridge, and one on the right, another H bridge. So it doesn't really look very H-shaped, but it's all there. We have 4 transistors, 1, 2, 3, 4. Those are our switches, so we're using transistors instead of the switch that we saw on the earlier schematic. And then the motor is connected to these out pins labeled out 1, out 2, and then the other H bridge has out 3 and out 4. So the motor, instead of being in between the middle here, comes off to the sides, and the power is coming in from the top. So here at A, we're connected to VS, and down here, we're connected B to the ground. So we've got the motor on the pins labeled out, the power comes in on VS and ground, and then the transistors here are controlled by the in and enable pins. So again, they're duplicated on each side for the 2 H bridges. One thing that's new in this schematic are these logic gates. So this is an AND logic gate shape here. So AND means that both input 1 and input 2 have to be logic 1 or true in order to get a logic 1 or true on the output. This is an AND gate as well, but the little circle there means it's an inverter. So in order to get a 1 going into this, you have to put a 0 in front of the inverter. So this is the combination that will get you a true on this AND gate. Those AND gates are used to prevent operating in the short configuration. The short circuit configuration is really bad. And so this is a clever arrangement that makes it possible to do forward, reverse, and brake, but you can't do the short circuit. So here we've got the forward arrangement. If we want to go into forward, again, forward and reverse are a matter of perspective, but forward we'll call when in 1 is on and in 2 is off. Normally the in pins are set for direction. The enable has to be on to go in forward or into reverse. So enable is always on, and then the combination of 1 and 2 give you the forward or reverse. But if we trace the wires, we've got enable on. So I've traced it in red here. So it goes up and it turns, this pin is on and this pin is on. So that's half of the AND gates is set by the enable pin. And the other half is set by the in pins. So in 1 is on. So we have a 1 and a 1 here. So we get a 1 at this top left. So this transistor is going to turn on. Down here, we have a 1 from in 1, but that hits the NOT. So this transistor is going to be off. On the other side, the enable A goes to this bottom part of the AND gate and the bottom part of the AND gate, and then in 2 travels across to the other side. So in 2 comes up here and it's off. So off in front of the circle means this AND gate is on, which means this transistor is on. So we have it on, and that's our forward configuration. In 2 comes up here, and since it's off, this AND gate will be off, and that's off. So in this configuration with in 1 on and enable A on, this is on and that is on, which gives us a plus on that motor pin and a minus on that motor pin. So we'll call that forward. So this is the reverse configuration. So again, we have enable A on in order to enable the H bridge at all, and then the direction is set with in 1 and in 2. So in 1 being off, in 2 being on. Again, the enable is just powering the bottom parts of all of the AND gates, so they're all ready to go. None of them will go if enable is off. And then in 1 is off, so the off up here means that this top left AND gate is off, so the top left transistor is off. In 1 being off goes into the inverter and turns on this bottom left AND gate, so the bottom left transistor is on. In 2 comes across, and we see it comes in here. In 2 is on, so it comes as off through the inverter, and so this one is off, and it comes up here and it's on. So this top right AND gate is on, which means the top right transistor is on. So we get a plus coming here on out 2 and a minus on out 1. Power comes through here and through there and back up to here, and the ground can come through there and out. So those are the configurations for forward and reverse, and that's the ones that we'll use the most. So the other advantage of having this enable set up, you can use it just like a safety, but it's really designed so that you have one pin that you can put PWM into, and you can drive the motor at various speeds. So what you normally do is hook the enable pin up to a pin on the Arduino that can do PWM, and then we give it a pulse train like this, and that will adjust the motor speed. From a duty cycle of 100% is full speed, duty cycle of 50%, half speed, and so forth. So the enable pin is normally connected to PWM. So once you buy the chip, you have to put it on a circuit board. So these are the little modules that we buy for this class. Most of you should have something like this. It's got screw terminal pins for the motors on each side and for the power input, because those are normally pretty fat wires. And it's got little header pins down here for the logic connections to the Arduino. So the motor connections are on the left and the right, pins 1 and 2, and pins 13 and 14. If you don't know how to connect the motor's got a red and a black, and you can just put them in. If you get them wrong, you can unscrew it and flip them around and put it back in, but you can also adjust the software to make the motor go the other way. The battery power for the H-bridge goes into pins 4 and 5 down here. So 4 is the positive and 5 is the negative, and you can't hook those up backwards or you'll break the chip. Pin 6 is a 5-volt pin, and it's used normally if we apply more than about 6 or 7 volts down here. Then there's a 5-volt voltage regulator on the board here, and it will create the logic of 5-volt voltage, and you can pull that out of pin 6. So if you put your battery in here, you can get 5 volts from pin 6. Another option, if your battery voltage is really high, if it's more than about 12, then this will get hot. And so you should pull this jumper that's connecting 2 little pins here under the yellow, and that disables the 5-volt regulator so it doesn't get hot, but then you have to supply 5 volts on pin 6, and ground shared here with the battery ground. So if you have a really high battery voltage, you can do this. If your battery voltage is below around 4.8 volts, if your batteries are dying down here, then again you won't get 5 volts on pin 6. And so again you can pull this to disable the voltage regulator, and you can give it 5 volts from maybe your Arduino board or something like that. So normally we leave this jumper on and we have 5 volts available here if we want it. And if our battery is in the range of 6 to 12 volts, that should work just fine. So next, we're going to show you a couple of ways to wire a battery to pins 4 and 5 down here. The easiest setup is the rechargeable battery, where we have a single battery pack of around 7 volts, usually a 2 lithium cell pack. The ground, the minus wire, the black wire on the battery, just goes to pin 5, that's our ground, and we also tie it into the Arduino's ground. Any of the ground pins on the Arduino can work. So we just run the black wire straight to both modules. The red wire comes out of the battery and into the switch, the middle terminal on the switch, and then one or the other of the ends goes to pin 4 to power your motors, and up here to V-in to power your Arduino. This is the Nano, but it's the same pin names with the Arduino Uno. And then the switch will turn the red wire on and off. The black wire is permanently connected. You always have to have all the grounds connected together, and you normally just want to switch the red wire. If you use the bottom terminal here instead of the top, it just changes which direction on and off are on a toggle switch like this. If you have the disposable batteries, you'll have 4 AA's for your motor. That's a 6 volt pack, and so that's not quite enough for the Arduino. It needs a good 7 volts or more. So then we use a 9 volt for the Arduino, and we have separate battery packs. For the Arduino module, we'll use the 9 volt, and for the motors, we'll use the AA's. So again, we connect all the grounds together to both boards. So we're connecting all the grounds just permanently to motor and Arduino. And then the switch, if you have this kind of a switch that's got 6 pins, then it's actually 2 switches in parallel connected together. So you can switch the 9 volt battery by running it on this side to the center, pull 9 volts out here, and remember 9 volts goes to the Arduino. Get your 6 volts to the center on the other side, and pull the 6 volts off here to drive your motor. That would be pin 4. So if you have 2 battery packs, you can switch them both with 1 switch this way, or you can use 2 switches wired up like this if you'd rather. If you have any questions about the wiring, definitely let me know. You're going to have a homework assignment to make a wiring diagram, so that'll be a good start. Okay, so here are the logic connectors. Again, it's these pins 7 through 12 on the bottom. When you buy this little module, it normally has jumpers. These are jumpers shown here on the outside pins that bridge pin 7 and pin 12 to the pins next to it, which is a 5 volt pin. So it ties those are the enable pins, it ties them high, and that way it's always enabled. So we want to be able to use the enable pins for PWM. So pull those little jumpers off and put them in a drawer. There's a jumper here for the 12 volt regulator that you want to leave on. Then you'll have all 6 pins down here. It's enable in 1 and in 2 for the both motors. So pin 7 is enable, 8 is in 1, 9 is in 2, 10 is in 3, and 11 is in 4. So that's the direction for the other motor, and then 12 is the enable for the other motor. So 7, 8, 9 for one motor, 10, 11, 12 for one motor, and the enable pins have to do PWM. Those are the outside pins. So make sure 7 and 12 are wired to PWM capable outputs on the Arduino. So there are a lot of tutorials and informative web pages out there. This is a very common module to use, the L298. If you Google L298 or L298N, you'll find a lot more information. A couple of web pages here that I like. They have example codes, so when you're writing motor test codes, you can look at something like this as a starting point. Okay, well that's plenty on the H-bridge, so I hope you understand the theory and some of the application, and you'll get to try it out very soon. See you in the next video.